Hello and welcome to Mr. A's Maths Today. Here is today's question. Give this a go. Pause the video when you're ready. So following on from yesterday, I thought it would be an idea to look at angles on parallel lines, but let's look at a slightly more challenging question. Yesterday's question turns out to be fairly easy. AE, DBG and CF are parallel. We can tell they're parallel by these arrows. DA, the length DA equals DB equals DC. What does that say about these two triangles? If this length is equal to this length is equal to this length, we have two isosceles triangles that might come in handy later on. It wants us to find x. So with this type of question, when it's quite complex, it's difficult to know where to begin. So let's try to work out what we can. These are two isosceles triangles. This is the first thing that's jumped out at me. This angle must be equal to that one. Does that help me right now? It actually doesn't, does it? If you can't remember the rules for angles on parallel lines, please pop back and watch yesterday's video. I discussed them all then. But I've just spotted we've got a Z shape. And if you remember yesterday's video, we're looking for Zs. Zs are called alternate angles. So this angle is equal to this one. The ones in the arms of the Z are equal. It says you must show your working. I'm going to give a reason. These questions often say give a reason. This one doesn't. It's worth 4 marks. This one doesn't. But I'm going to give one anyway. I'm going to say alternate angles are equal. Alternate angles are equal. The word equal is important. Don't just call it an alternate angle. You need to say it's equal. It is also equal. What does this tell me? This is an isosceles triangle. So I know that this one is also 38 degrees. It's always the angles opposite the little lines are equal. So I'm going to give a reason for this as well. And this is a reason people often forget. Base angles of an isosceles triangle are equal. I think I'm almost there because I can now work out this angle. I need to do 180, subtract 38, gives me 142. So I'll subtract this one, I'm going to subtract this one, take off another 38, gives me 104. So I know this angle is 104. In your exam, don't be afraid to mark your diagram, to put words on your diagram, to put numbers. You will often get marks for doing this. Build up till we can find the right answer. I'm going to put a reason on for this as well. Angles in a triangle. Sum, add up to, sum to 180. The word sum is very important. If you say angles are 180, angles add to 180, but you don't mention the word triangle, you're going to lose the mark. If you say a triangle adds to 180, you'll lose a mark because it's not the triangle itself, it's the angles that sum to 180. So I think we're nearly done because we said this one is the same as this one. It's a congruent triangle, this. Congruent triangles, this triangle is identical to this one, it's just that it's just being flipped. So now we've got 104 and 104. Need to do a bit more of a sum. I need to do 360. Subtract 104, subtract another 104, subtract 208. Leaves you with 152. X is 152. Which is the answer I'm looking for. I'm going to put my reason in. Angles around a point. sum to 180. They're not angles in a circle, it's angles around a point. Angles around that point, sum to 360. So there was quite a bit of working out for this one. As I say, it didn't ask for reasons, it just said show your working. I wanted to show you the reasons because it often says show your reasons. Don't be surprised if you've got quite a bit of writing on this type of question. As I said, quite an involved one, a bit more challenging. Here's one for you to try, put your answers in the comments. A maths question a day keeps the bad grades at bay. Tune in tomorrow for another maths question. See you soon.